Hi all, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. The topic is Definitions and Terminology of Chemical Energy Based Process. Okay. So from this unconventional machining process, we are discussing particularly the chemical based process. Okay. Chemical energy based process. So at the end of this session, student will be able to define the chemical energy based process and the corresponding parameters or what is that called terminology. Okay, right. Copper and copper alloys, titanium, aluminum, graphite, platinum, tungsten carbide, brass, bronze, carbon, monel, and reinforced plastic. Okay, right. Define ECM. It is the controlled removal of metals by the anodic dissolution in an electrolytic medium where the workpiece and the tool, workpiece is anode and tool is said to be cathode, are connected to the electrolytic circuit, which is kept immersed in the electrolytic medium. Okay, so in electrochemical machining, the workpiece is dipped or immersed in electrolytic medium and work is anode and the tool is cathode. Okay. Define Faraday's first law of electrolysis. The amount of any material dissolved or deposited is proportional to the quantity of electrolyte passed. Okay. So here the amount of material dissolved or deposited is proportional to the quantity of electrolyte passed. Okay, electrolyte passed. Okay, the amount of any material dissolved or deposited is directly proportional to the quantity of electrolyte passed. Okay, this is electrolyte, this is material. Okay. Define Faraday's second law of electrolysis. The amount of different substances dissolved or deposited by the same quantity of electricity are proportional to their chemical equivalent weight. Okay, the amount of different substances dissolved or deposited by the same quantity of electricity are proportional to their chemical equivalent weight. Okay, that is the second law of Faraday. Define Ohm's law. Okay, right. 1 ohm is defined as the resistance of an object when a current of 1 ampere flows through an object having potential difference of 1 volt. Okay, so usually ohms, that means resistance. Okay, so resistance unit is ohm. Okay, that is this one. This is resistance. Okay, so here resistance is directly proportional to the ratio of voltage to the current. Okay, so 1 ohm equal to 1 volt by 1 ampere. Okay, so 1 ohm is defined as the resistance of an object when a current of 1 ampere flows through an object having a potential difference of 1 volt. Okay, right. What are the factors that influence oxidation in ECM? Nature of workpiece, type of electrolyte, current density, temperature of the electrolyte. Okay, so these are the factors influence the oxidation, okay, in ECM. Nature of workpiece, type of electrolyte, current density, temperature of the electrolyte. Okay, so these four influence oxidation in ECM. What are the main functions of electrolysis in the electrochemical machine? So these are the main functions of the electrochemical machines. Okay, functions of the electrolysis in the electrochemical machine. Okay, for completing the electric circuit between the tool and the workpiece and allow to the reaction to proceed efficiently. Okay, for completing the electric circuit between the tool and the workpiece and to allow the reaction to proceed efficiently. Second, to remove the products of machining from the cutting region. So obviously after cutting or machining, the debris will be near around the tool and the workpiece, so that it has to be removed. Okay, so that will be carried out by the electrolysis process. Okay, to carry away the heat generated during the chemical reaction. Okay, so to carry away the heat generated during the chemical reaction, definitely whether it may be in an indirect contact, some heat would be generated, so that heat to be carried out during the chemical reaction. To avoid ion concentration at the workpiece tool gap. Okay, it cools the cutting zone, which becomes hot due to the flow of high current. Okay, so this electrolysis, that is nothing but electrolyte, reduce the heat that has been produced because of the flow of high current. What are the properties are expected from the electrolysis used in the electrochemical machining? High thermal conductivity, low viscosity and high specific heat, should chemically stable even at high temperature, should be non-toxic and non-corrosive. Okay, so these are the essential properties of the ECM electrolysis process. What are the electrolytes commonly used in electrochemical machining? 15 to 20% NaCl in water, sodium nitrate, potassium nitrate, sodium sulfate, sodium chromate and potassium chloride. Okay, potassium chloride and there is sodium chloride. This is sodium chloride in water. 15 to 20% sodium chloride in water, sodium nitrate, okay, potassium nitrate, sodium sulfate, sodium chromate and potassium chloride. Okay, what are the results due to improper selection of electrolyte in ECM? Low machining rate, overcut and stray cutting. Okay, low machining rate, overcut and stray cutting. Okay, right. What are the methods generally used to filter? First one is running the system until it is contaminated completely and replaces it. Okay, running the system until it is contaminated completely and replaces it. Centrifugal separation. Third one, sedimentation. Fourth one, use of clarifiers. Okay, right. What are the characteristics or requirements of a good ECM tool? It should be a good conductor of electricity and heat, easily machinable, resistant to chemical reaction. It offers resistance to the high electrolyte pressure. Okay, so let me read out the characteristics of a good electrochemical machining tool. It should be a good conductor of electricity and heat, easily machinable, resistant to chemical reaction. It offers resistance to the high electrolytic pressure. Okay, right. What are the parameters that affect the material removal rate, MRR? Okay, feed rate, voltage, concentration of the electrolyte, temperature of the electrolyte, current density, velocity of the electrolyte. Okay, so these are the parameters that affect the material removal rate. Okay, feed rate, voltage, concentration of the electrolyte, temperature of the electrolyte, current density, velocity of the electrolyte. Okay, right. How the current density affect the material removal rate? Okay, current density is controlled not only by the amount of current but also by the size of the gap between the tool and the workpiece. Okay, a small gap results in high current densities, which in turn produce more material removal. Okay, current density is controlled not only by the amount of current but also by the size of the gap between the tool and the workpiece. Okay, a small gap results in high current densities, which in turn produce more material removal. Okay, what are the advantages of electrochemical machining? So the following are the advantages of electrochemical machining. It is simple, fast and versatile method. Okay, simple, fast and versatile method. Surface finish can be extremely good. Fairly good tolerance can be obtained. No cutting forces are involved. Wear and tear of tool is negligible. Metal removal rate is high. Okay, MRR is high. Okay, what are the disadvantages of ECM? Okay, what are the disadvantages of electrochemical machining? Large power consumption and the related problems. Okay, so here the power consumption is very large. Next, non-conducting materials cannot be machined. Okay, non-conducting materials cannot be machined. Okay, next, maintenance of higher tolerances are important parameters. Okay, which are complicated in terms of contours. Okay, maintenance of higher tolerances require complicated contours. Initial investment is quite high. Okay, more space is required. Okay, so for the electrochemical machining process, the setup is somewhat bigger in order to maintain the entire chemical inflow and overflow and outflow. We must have more space. Okay, next, define ECG or state the principles of ECG process. Okay, so ECG means electrochemical grinding. ECG. Okay, electrochemical grinding. Okay, so electrochemical grinding is the material removal process in which the material is removed by the combined effect of electrochemical effect and conventional grinding operation. Okay, so here the grinding tool will be cathode okay, and the tool, so that it will act as the conventional grinding tool and it will be affected by the electrochemical effect. Okay, so it has combined effect of electrochemical effect and the conventional grinding operation. Okay, right. The major portion of the metal, that is 90%, is removed by the electrochemical effect only. Okay, direct contact would not be required. Okay, so remaining 10% will be removed by the grinding action. Okay, so 90% will be removed through the electrochemical effect. Right. Which materials used to make the grinding wheel? Okay, first one is metal bonded diamond or aluminum oxide, Al2O3. Okay. Otherwise, we have to use carbides. Okay. What are the important functions the abrasive particles used in this is electrochemical grinding? Right. It acts as insulator to maintain a small gap between the wheel and the workpiece. Okay. They are electrolysis products from the working area. To cut chips, if the wheel should contact the workpiece, particularly in the event of power failure. Okay, here to cut chips, the wheel should contact the workpiece, particularly in the event of power failure. Right, what are the limitations of electrochemical grinding? Okay, first one, the work material must be conductive, not suitable for machining soft material, require dressing tools for preparing the wheels. Okay, so here dressing means removing the debris which is occupied the areas of grinding wheel. Okay, so in grinding wheel there will be some gap between the each uh, grinding material, so that this debris will occupy that space. So we have to remove that debris. So that is nothing but dressing. So before we conclude, let us fastly rewind the entire thing. Okay, ECM. Okay, so in the control, it is the controlled removal of metals by anodic dissolution in an electrolyte medium, where the workpiece and the tool are connected to the electrolytic circuit, which is kept immersed in the electrolytic medium. Okay, first law of Faraday: the amount of any material dissolved or deposited is proportional to the quantity of electrolyte passed. And the second law of Faraday: the amount of different substances dissolved or deposited by the same quantity of electricity are proportional to the chemical equivalent weight. Ohm's law. Okay, R equal to V by I or V equal to Ri. Okay, so from this we can define. Okay, so here is the ratio of 1 volt to 1 ampere. Okay, and what are the factors that influence the oxidation? Okay, nature of work, type of electrolyte, current density, temperature of the electrolyte. Okay, right. What are the methods generally used to filter? Running the system until it is contaminated completely and replaces it. Next one, centrifugal separation. Third one is sedimentation process. Next, use of clarifiers. What are the characteristics of a good ECM tool? should be a good conductor of electricity and heat, easily machinable, resistant to chemical reaction. Okay, it offers resistance to the high electrolyte pressure. Okay, what are the parameters that affect the material removal rate? Feed rate, voltage, concentration of the electrolyte, temperature of the electrolyte, current density, velocity of the electrolyte. So these are the various parameters that affect the material removal rate. Okay. So with this, we can conclude. Okay. Thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.